this video is gonna have a little bit of everything. Okay, I'm gonna have to evaluate, solve, and we have a multiple choice, which is equivalent to, they give me the expression. And we're just gonna apply everything that we've learned up till now. Here, I still have the logarithmic properties. Now, I erased the two bottom ones to write this one. So this one is one that we have to have memorized. It's called the change of base. The reason why this is so important is because our handy dandy calculators, like a professor of mine used to say, idiot boxes, because they can't even perform order of operations. So it's limited. It's great help if we know how to use it. So I'm gonna teach you how to use this and how to find and evaluate an expression like this with logarithmic expression. Now, I wrote this little squiggly equal sign because it's an approximation, right? So, is there a way on your calculator that you can write a log with a base of 2 or any other base other than 10 or e? No. Okay. Calculators, unless there's a new calculator out there that does it, but for the most part, your calculator cannot, there's no way of telling your calculator, hey, when you take the log of this, make sure it has a base of 2. No. When you hit the log function on your calculator, when you hit log on your calculator, it is standard that is the common log. So the log on your calculator will always, and I'm going to repeat this, the log on your calculator will always have a base of 10. Okay? It also has the function for the natural log, right? ln. That one we know has a base e. Okay? So how would I go about solving this or evaluating it with my calculator if I can't type in that base there? This is where change of base comes in handy. Okay, a change of base property states that if I have a log with some base b, okay, then I can rewrite it as log base 10. And then I'll write the m, so whatever, all right, and then the base, I take the log of the base, okay? So the base is no longer the base. Both of these have a base of 10, right? It's not, there's nothing written there. So we know that it's a base of 10, okay? So that's how we would solve this, and that's what we need here, okay? So following that, I like to remember it as whatever my base is, I'm gonna put in the basement of my fraction, okay? So my base is 2, so I can rewrite this as remember my base will go in the basement, so log base 10, which is convenient because that's what our calculator likes, okay? And I'm gonna take the log of my base, or log of 2, because my base is 2 here, okay? And then I take the common log of 1024, okay? Again, both of these logs have a base of 10. So I can just go in and write log on my press the log function on my calculator, and then just type this. Okay. Now, I would be careful with typing all of this together. Okay. And when you divide here, use the actual division sign instead of the dash or the forward slant, right? So I would suggest you use this one, this symbol, instead of this one, okay? Mainly because on some calculators, if you use this one, it's gonna say syntax error, okay? So this one will work, okay? So I'm gonna this is the one that we wanna use, okay? Now, instead of writing all of this out, what I like to do is, because again, our calculators can't perform order of operations, so I don't think there would be any problem here, but it's good to get into the habit, okay? So I like to do things in parts. So first, I'm gonna type this in and say log of 10, 24, close parentheses, enter, okay? It's gonna give me a long number, okay? I hope you have your calculators there, okay? The log of 1024 is equal to 3.010299957, and it probably continues, okay? Now, do not round, do not round. Once you hit enter and your answer's there, that long decimal, go ahead and just hit this function, right, to divide, okay? And then once you hit the division sign, we can just type this one in. So go ahead and type in log of 2, close parentheses, then hit enter again, okay? And this is actually not an approximation. It actually came out to a whole number. So my answer would be 10, okay? Again, I'm going to stress, the only time you should round is on your answer, the last one, okay? If you round in here, your answer is going to be different. So make sure to do it in parts. Do this one first, hit enter, then hit divide, then do this one, and then enter. Okay, now this one says solve. Now, we're gonna have to apply the things that we've learned. Taking a look at this one, this will be an exponential function. I don't see any logs, and I have a variable as an exponent, so this is an exponential function. In order for me to solve exponential functions, I have to convert back to a logarithmic function, because that's the only way I can bring down this variable, which is what we're trying to solve for, okay? But before we do that, just like I expressed in the previous video, before I write into a single quantity or before I start solving, okay, and I get it down to this, anything that's being multiplied to my base of this exponent we have to get rid of it, okay? The base has to be alone. And I can't just multiply these two and say negative 200, because exponents go before multiplication, okay? And not only that, actually I don't think that really matters. But before we move from one to another, notice my base is alone. There's nothing being multiplied to that base. In this case, this b would be 2. My y would be 0.5x, okay? So this has got to go. So if I'm multiplying this to all of this, then if I divide by negative 100 to both sides of the equation, then negative 100 divided by negative 100 would just be 1, which I can get rid of. Okay, so I'm going to rewrite this and say I'm left with a 2 raised to the 0.5x, or the power of 0.5x, equals, I have a negative with a negative, so my answer, this is going to be positive. I can simplify here, which will be 1 over 20. Okay, now I got it looking like this. My base is alone, raised to some power, it's equal to x. Okay, so now I want to go this way to the logarithm form. So log, this is my base. Okay. Now what I'm going to take the log of is whatever it's equal to. So 1 divided by 20 is equal to my exponent. So 0.5x. Okay, nice. Now that we have, we got the x down from being an exponent, now we can solve for x. Now, 0.5 is being multiplied to x, so what I'm going to do here is divide. So I'm going to divide by 0.5 to just isolate that x. 0.5 to both sides. This becomes 1. So I'm left with x equals all of this. Okay. Now, again, I'm going to have to type this in my calculator. And I have a log base 2. I can't write that on my calculator. So just for this top portion, I'm going to use the change of base so that I can type it in my calculator. Okay, and I'm going to get a little lower here so I can write this section. So I have x equals, and what I'm going to do is grab this top one and do the change of base. Remember, my base is going to be in the basement. So log of 2, and then this one is going to be as my numerator. Okay, and this is the change of base for this top one, so I can type it in my calculator. But it's all being divided by 0.5. Now, this looks really ugly. I have a fraction being divided, fraction with a fraction, okay? It's okay. Okay, let's focus on the top first, okay? Just like we did here. Okay, so let's type this in our calculator. And it'll be nice if you follow me so that you can see and practice typing this in your calculator, getting to know your calculator. So I'm just gonna go ahead and type this first one, log, and do fraction 1 over 20, close parentheses, and then I'm gonna hit enter. Enter is going to give me a long decimal, -1.3010299. Okay, once I hit enter, then I'm going to hit the division sign. Okay, and then I'm going to write the bottom. Divided by log of 2. Hit enter. And I got it again. For this, I got a long decimal, which is -4.3219280. Okay, again, do not round those numbers. Okay, so it's there. The last thing I have to do is divide by 0.5. So I'm just gonna hit the division sign again, 0.5, hit enter, and my answer, so here, x equals -8.64. And I can round this, my answer. That's the only one I can round. I can round my answer. Now, it wasn't stated to round to a certain, so I'm just gonna round it to 2 decimal places. Okay, so x equals negative 8.64. Hopefully you could, that's in the video, I think you could see it. This last one. Okay, I'm gonna apply my properties here. Okay, which is equivalent. Okay, so I have 2 logs and they got it down to just one single quantity. Okay, so I take a look at this log base 10 of A. Can't really do anything there. And I don't have a property where I'm multiplying 2 logs. See? This is not the same. Okay? This is not the same. I'm multiplying 2 functions. Okay? And the only ones I see here is addition and subtraction. Okay? So I'm gonna move on and look at this one. Okay? Well, if I take a look at that, I feel like I can apply the change of base. Okay? I can apply the change of base property here. So I'm gonna grab this one. And I'm gonna use the change of base property. So I'm gonna rewrite this and say log 5 divided by log A. Okay, and then of course all of this, right? So this is equal to that, and it's being multiplied by the log, running out of room here, log of A. Okay. Okay, so the log of A is being multiplied to all of this. Which is nice. This is nice because look, I'm multiplying here, so I'm left with log of A times the log of 5, and all of that is being divided by log of A. So you know how to multiply fractions, right? This is kind of like has an imaginary 1 underneath as a denominator. So I just multiply numerator with numerator, denominator with denominator. Now, take a look at this right here. I have log A being divided by log A. Same quantities being divided, okay? I can cancel because that's 1, right? It's like saying 5 divided by 5. You see, same quantities always equals 1. If I have x divided by x, same quantities, it equals 1. Same quantities, so it equals 1. So I'm left with 1 times all of this, which is just log of 5. So my answer would be answer choice B. So hopefully this makes a lot more sense. Make sure you study up on these properties.